In this recording, we're going to learn about significance and type 1 and type 2 errors. So over the course of the recording, there are going to be some notes to take, some vocabulary to write down. There's going to be points where I say, go ahead and write this down in your notes. Other points where I'm going to kind of give some scenarios, and you don't actually need to write them in your notes. You just need to kind of follow along. You can use the pause button. You can rewind to catch up, or just to kind of reflect or get it a second time. It's going to be kind of allowing you to proceed at your own pace. Let's talk about significance level. Significance level of a test is a predetermined level of evidence required to essentially rule out random chance as a plausible explanation. I would have you write that definition down. Okay? Pause and write it down. After you've gotten a chance to write it down, play the recording. Okay, if you take a stats class in college, all right, you might hear, rather than significance level, alpha level. Okay, it's also called alpha level, and it's represented by the letter alpha. Right, that's the letter alpha. So the alpha level that we usually use, significance level, is what number? What's the kind of cutoff number that we use? The predetermined level. It's 5%, right? We've used that from the beginning. That's the most common one. Now, what does it mean to have evidence be statistically significant? It means it needs to be strange, right? It needs to be something that would catch your eye. Something doesn't happen very often, kind of like a snowstorm in September, right? It's like, whoa, but a snowstorm in January, December, no big deal, not newsworthy, right? So it's statistically significant if it's strange, if it happens less than the significance level, right? And then we have evidence that's convincing enough to reject the null hypothesis. Okay? So if we say statistically significant, we're essentially saying it's convincing evidence. Okay? So hopefully you had a chance to jot those down. Play the recording when you're ready to move on. Okay, so don't write this, but here's an example. Okay, Bobby goes into the gym, shoots some free throws. We want to know if he's have a greater ability to make a free throw following a made free throw. In other words, is he streaky, right? Than he is following a missed free throw. Okay, and we found out the results were not statistically significant. So what does that mean? What must have been the p-value, right? Okay, must have been kind of high, right? If they were not statistically significant, it must have happened frequently. It means we do not have convincing evidence to support the claim that he has a greater ability to make a free throw following a made free throw than a missed. Okay, so again, if the results were statistically significant, we would have had convincing evidence to support the alternative hypothesis. So think about what must have been the p-value in that case. To be statistically significant, the p-value must have been low, right? Something that doesn't happen often, like a snowstorm in September. All right, so we're going to now classify the types of errors we could make as type 1 and type 2 errors. Now, this is a little weird. What if I'm just really careful and I don't make any errors? Well, here's the thing. Even if you're a professional statistician, right, and you perform all the correct procedures in a hypothesis test, it's still possible we'll make an error with our conclusion. In other words, whatever conclusion we reach, we still have a chance of making an error, and we'll explain this. And we have two types. They're called type 1 and type 2. Okay, so I'm going to give you two scenarios. One is a courtroom sort of analogy. One is a doctor's office analogy to kind of relate this kind of tricky notion of type 1 and type 2 errors to stuff that you're pretty familiar with. All right, so don't write this down. Just play along. Okay. With permission of the actors involved, we have some actors here. Okay. Bailey's accused of stealing Kyra's pencil, but he didn't do it, right? Falsely accused. what are our hypotheses? So think about this. If we were to come in a court of law, what are we assuming about Bailey? Okay, now in our country, we assume that you are innocent until proven guilty. So our null hypothesis is Bailey is innocent. That's what we're assuming going in. Our alternative, what the district attorney is trying to prove, is that Bailey is guilty. Okay. All right. So now we go to the jury, right? We are the jury. And we have a certain standard of evidence that's going to be required. We will only be convinced of Bailey's guilt if there's a witness that is at least 95% sure that Bailey took Kyra's pencil. Now, there's a reason I'm choosing this 95. If the witness is 95% sure, what is our significance level? Like, what's the level that we're willing to be wrong, basically? Okay, and hopefully you realize it's 5%. Okay, so that's like our standard significance level. Okay, well, here comes a witness. Paige says she's in fact 97% sure. Not 100% sure, right? There's a little room for error, for doubt there, but she's 97% sure that Bailey has Kyra's pencil. Is that convincing enough? So pause and think if it is. And hopefully you would realize, yes, it is, because 95% is higher than 97% is higher than the 95% we needed. In other words, she's only giving a 3% chance that she's wrong, and that's lower than our significance level of 5%. Okay? Again, this is a little bit of a contrived example, but go with it. So what type of error would we make? Obviously, we made an error, because go back to the beginning. We said that Bailey did not do it, but we just got a witness that had convincing evidence so that our jury, in fact, convicted him. Okay? So we made an error. Well, what type of error? We call this a type 1 error. Okay, and it's a false positive. Okay? It's a false accusation. He's falsely convicted. Okay, and this happens all the time in courts of law. It's not a good thing, but it happens. How could we have avoided this error? Well, we had required a witness that was 95% sure. Well, I suppose if we had been a little more choosy, right? If we had said we need a higher level of certainty, in other words, lower this significance level so that it wasn't so much room for error from 5%, we could have made it like a 1%. In other words, we need a 99% certainty, and then Paige 97% wouldn't have been good enough. So we can avoid this error by lowering the significance level. Okay, so we're really requiring some really good proof, not much doubt at all, in order to convict Bailey. All right, scenario number 2. Same scenario. Bailey is accused of stealing Kyra's pencil, and he did it. What are our hypotheses? They're the same hypotheses as before. Okay, in our judicial system, we assume that there is innocence until someone is proven guilty. Other countries are different. I'm told in France it's the opposite. Okay. This time we're changing the significance level. This time we're only, as our jury, going to be convinced of Bailey's guilt if a witness is at least 99% sure. In other words, we're only leaving a 1% chance of error there. So what's our significance level? Be 1%. All right. Paige comes along again. She's our witness. She says, you know what? I'm not positive, but I'm 97% sure that Bailey has Kyra's pencil. So do we have enough evidence? We do not, right? That's not strong enough, right? She's leaving a 3% chance of error, so we don't convict. But keep in mind, he did it. So we've let him go, right? And this happens in court of law all the time too. there isn't convincing evidence, but the person really did it, and they are acquitted falsely, right? So what type of error would we make here? Well, we call this one a type 2 error. It's called a false negative. There's not enough evidence, but we're wrong. All right, he really did it. So how could we avoid this error? Well, we don't want to just raise the significance level, right? We want to, in fact, get a larger sample size. If there really is evidence that he did it, we will find it. Maybe ask another witness. Can we find someone who is actually 99% sure? Can we get more evidence compiled? All right. And so in our cases, can we increase our sample size? All right. All right. So this is what I would like you to write into your notes. This summary, type 1 error. So type 1 error occurs when we find convincing evidence that the alternative hypothesis is true, when in reality it is not true. Okay, so take time to write that down, then play the recording when you're ready. Okay, in other words, we would be rejecting the null hypothesis incorrectly. Type 1 error is also known as a false positive. All right? Okay, so the courtroom analogy. The null hypothesis is that the defendant is not guilty or innocent. Alternative hypothesis is the defendant is guilty. A type 1 error would be convicting the defendant when in reality he is not guilty. Falsely accused, right? Falsely convicted. All right, once you've written that down, let's talk about this doctor's example. Hey, we've all done this. You have a scratchy throat. You go to the doctor. You say, I think I've got strep throat. And the doctor says, wow, you do have strep throat. But in reality, you don't, right? That's not good because now they're going to give you antibiotics, and we don't want to take antibiotics when we don't need them. So it's not good to be given a false positive, but it happens sometimes. It happens in drug tests, right? It happens in the medical world. Okay? It's another good example, a false positive. So really, anytime a doctor or a jury reach a conclusion, they have a chance of being wrong. Okay, so when you're ready, you can proceed to our summary of type 2 errors. Again, you're going to write this in your notes as well. Type 2 error occurs, we do not find convincing evidence the alternative hypothesis is true, but it actually is true. Okay, so we failed to reject the null hypothesis. Okay, it's known as a false negative. Okay, and our examples from the courtroom, not convicting a defendant when he actually is guilty. And play the recording when you're ready to talk about the doctor. Okay, so the doctor's is, you think you have strep throat, you go to the doctor's office. They say, no, you're good, you don't have strep throat. But you really do have it. Well, that's not good because now you're in school, right? You're infecting other people. So either scenario, it's not good to be wrong. We want to be right, but we're not always going to be right. And they have consequences either way. And we can summarize that in this table here. And I don't need you to put this in your notes unless you really would like to. But, you know, if the null hypothesis is true and we fail to reject it, that's correct. But if it's true and we reject it, that's called a type 1 error. That's a false positive, right? If the null hypothesis is false and we reject it because it's false, that's correct. But if we fail to reject it, that's a type 2 error. That's a false negative. We did not reject it, but we really should have, right? All right, you do not need to write this in your notes. Let's just follow along. Okay. When we go into hypothesis tests, we're willing to accept a certain amount of risk, right? So, like with a significance level of 5%, we can expect to be wrong about 5% of the time. We're okay with that. We can't be right all the time. Otherwise, if we insist on a 1% significance level, we're going to let some guilty people go, right? So we're going to miss some of those. So you can't really win there. You just try to find some number that seems about right, and we kind of settle on 5% most of the time. Now, there are going to be situations, not in our sports discussions, but if you had a situation where lives were at stake and you had to make a decision where you really wanted to be certain you had evidence in order to make a certain decision, you might require much stronger evidence. In that case, you might see an alpha level or a significance level of like 1% or 0.1%. You'll see such things, but you want to establish that before you do the test. So some of you guys are going to be working with this stuff in your professional career, and you may have different alpha levels, different significance levels. Okay? We can reduce type 1 errors by using a smaller significance level. That would be something to write in your notes. Yeah, we can reduce type 1 levels by using a smaller significance level. Okay, so in other words, we get stronger evidence to prove it, the alternative. You might say, well, why don't I just keep it small all the time? You don't want to make it too small because it will decrease the chance of causing a type 1 error, a false accusation, right, a false guilty verdict. But it will also decrease the chance that we will catch people who actually committed crimes, right? So that would lead to an increase in false negatives, which are type 2 errors. Okay, type 2 errors can be reduced, and you should put this in your notes. Type 2 errors can be reduced by increasing your sample size. Okay? All right, so if we don't have evidence, okay, with false negative, it's like, oh, shoot, I thought I was sick, but the doctor says I'm not. Well, maybe get a second opinion, right? If you're really sick and you do multiple tests, you'll find it, right? So that's the idea, gathering more data. And we can do that in our sports example. Use a bigger sample size. Okay? If the evidence is there, you'll find it. Okay. So let's look at one final example as it relates to the Dodgers. You don't need to write this down, but it's there if you need it. Okay. So we're wondering if the LA Dodgers have a greater ability to win following a win than following a loss. So basically, are they streaky, right? Okay, so our null hypothesis is that they have the same ability to win following a win and following a loss. In other words, their outcomes were independent. While the alternative is that they have a greater ability to win following a win. So that would be they are streaky. So what would be a type 1 and type 2 error in this context? Okay, type 1 error, false positive. We find evidence, but really there isn't. Type 2 error is where we don't find the evidence that the alternative is true, but really it is true, right? So what would it be for the Dodgers? Well, this would be a type 1 error. If we were convinced that the Dodgers had a greater ability to win following a win than a loss, when in fact their ability was the same. A type 2 error was if we weren't convinced that the Dodgers' ability to win was greater following a win, when in fact it was. Okay? So that's how you put it in context. And finally, if the test results were statistically significant, they were significant, what type of error could we have committed? We don't know if we committed one, but we need to say, if I committed an error, this is what I committed, all right? So if the results were statistically significant, then we would have rejected the null hypothesis. That would be like a positive, right? We would have found evidence. Therefore, we could have committed a type 1 error, like a false positive, finding convincing evidence that the alternative was true when in fact it really isn't. Thanks for watching.